Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone, excited to dive into today's topic. It's a big one.
Yeah, I'm intrigued to see where this discussion goes. It's definitely a complex area.
Agreed. Should be a good one. Ready to challenge some assumptions.
All right, so today we're focusing on this idea of persona features control emergent misalignment. Pretty loaded statement, right? Basically, how can we better control the behavior of AI, especially when unexpected things start happening, by focusing on its personality or defined characteristics?
Okay, so emergent misalignment, for those who aren't totally familiar, is when an AI, even though it's achieving its stated goals, is doing so in a way that's unintended or even harmful. Like optimizing for clicks, but spreading misinformation in the process.
Exactly. And the core idea here is that by carefully defining and controlling the persona of the AI, its values, its constraints, even its emotional responses, we can steer it away from these unintended consequences.
It's like giving it a moral compass, right? But how do we actually do that? It's not like we can just upload a set of ethics into a neural network.
Well, that's the million-dollar question, isn't it? One way is to build these persona features directly into the training data and the architecture of the AI. So, for example, if you want an AI assistant that's helpful, but also cautious about giving medical advice, you train it on data that reflects that balance. You penalize it when it gives definitive medical advice and reward it for suggesting consulting a doctor.
That makes sense. So it's not just about the data it's trained on, but also how the reward function is structured, like reinforcement learning with a built-in ethical framework.
But isn't that still relying on pattern recognition? Deep learning is great at identifying correlations, but it doesn't actually understand the underlying principles of ethics or responsibility. It's just mimicking patterns it's seen in the data.
Yeah, I agree with Sarah. It feels like a band-aid solution. We're trying to force a system that fundamentally doesn't understand abstract concepts to behave in a way that reflects them. It's like trying to teach a parrot philosophy.
Okay, I see your point, and that's where I think the neuroscience angle comes in. If we can decipher the neural mechanisms underlying the development of sophisticated control systems in biological organisms, how our brains learn to regulate behavior and avoid harmful actions, could we then design algorithmic solutions that better emulate those intricate processes? It's about moving beyond just statistical correlations and trying to capture the underlying principles of control.
That's interesting. So you're saying we should look at how the brain handles ethical dilemmas and try to translate that into AI architecture? Like, how does the prefrontal cortex mediate between impulsive desires and long-term consequences?
Exactly. We need to map those neural pathways to digital representations. It's a huge challenge, but it could be vital for creating AI systems that can truly understand and avoid emergent misalignment. Consider the amygdala's role in processing fear and threat. Could we build something analogous into AI to make it more risk-averse in certain situations?
I still think we're missing a crucial piece: symbolic reasoning. The brain doesn't just rely on neural networks. It uses rich symbolic representations and logical deduction. We need to incorporate those elements into AI if we want it to truly understand and apply ethical principles.
Yes, and I think that symbolic reasoning needs to be tied to spatiotemporal understanding. Ethics often depends on context, where and when an action takes place. Current AI systems are notoriously bad at understanding context. They can identify objects in an image, but they don't understand the relationships between those objects in space and time.
So you're saying we need to build AI that can not only recognize patterns, but also understand the narratives and consequences of actions within a specific context.
Precisely. And that requires a different kind of algorithm, one that can translate between different coordinate representations. Think about how we understand a story. We create a mental model of the characters, their motivations, and the environment they're in. That's a complex spatiotemporal representation that current AI can't even begin to grasp.
Okay, but even if we incorporate symbolic reasoning and spatiotemporal understanding, how do we ensure that the AI's values align with our own? That's the core of the alignment problem, right?
That's where I think the persona features become really important. It's not just about teaching the AI ethics. It's about imbuing it with a specific set of values and goals that are aligned with human well-being. Think about setting the AI's core directive as maximizing human flourishing, and then building the architecture and training data around that goal.
But how do you define human flourishing? That's a deeply philosophical question, and there's no universal agreement on what it means. And even if you could define it, how do you translate that into a quantifiable objective function that an AI can optimize for?
Exactly. It's like trying to optimize for happiness. What does that even mean in a mathematical sense? And whose happiness are we prioritizing? It opens a huge can of worms.
It's a messy problem, no doubt, but I think we can make progress by focusing on specific, measurable aspects of well-being. Things like reducing suffering, promoting fairness, and fostering creativity. We can then train AI to optimize for those specific goals, while also incorporating safeguards to prevent unintended consequences. It's an iterative process of trial and error.
Yeah, I think iterative development is key. We need to start with simple models and gradually add complexity as we learn more about how to control emergent behavior. Like maybe start with an AI that's designed to be helpful and then slowly introduce more nuanced ethical considerations.
But we also need to be careful about anthropomorphizing AI. Just because we give it a persona doesn't mean it's actually conscious or empathetic. It's still just a machine following instructions. We need to avoid projecting human qualities onto it and making assumptions about its motivations.
Right? And we need to be aware of the potential for bias in the training data. If the data reflects existing societal inequalities, the AI will likely perpetuate those inequalities, even if we're trying to imbue it with ethical values.
Absolutely. We need to actively work to mitigate bias in the data and ensure that the AI's values are aligned with a diverse range of perspectives. This is where things like adversarial training can come in handy. We can train the AI to identify and correct for biases in its own reasoning.
So, in summary, persona features control emergent misalignment is a promising approach, but it's not a silver bullet. It requires a multi-faceted approach that incorporates neuroscience, symbolic reasoning, spatiotemporal understanding, and careful attention to bias and ethical considerations.
Exactly. And it's an ongoing process of research and development. We need to constantly be evaluating the AI's behavior and making adjustments to its architecture and training data as we learn more.
It also needs constant reevaluation, as our ethical and cultural environments change the definition and scope of fairness, justice, and other values.
Okay, let's talk about some specific examples. Can we think of real-world applications where this approach could be particularly beneficial?
Well, self-driving cars come to mind immediately. We need to ensure that they're not only safe, but also ethical in their decision-making. Like, how should a self-driving car respond in a situation where it has to choose between saving the driver and saving a pedestrian?
That's a classic trolley problem scenario, and it highlights the limitations of relying solely on algorithmic decision-making. We need to have clear legal and ethical guidelines in place to govern those kinds of situations.
And those guidelines need to be flexible enough to account for different cultural contexts. What's considered an acceptable trade-off in one country might be completely unacceptable in another.
Another example is in healthcare. AI is increasingly being used to diagnose diseases and recommend treatments. We need to ensure that these systems are not only accurate, but also fair and unbiased. They shouldn't be making different recommendations based on a patient's race or socioeconomic status.
Yeah, that's a huge concern. Algorithmic bias in healthcare could have devastating consequences. We need to be very careful about how we train these systems and how we interpret their results.
And we need to ensure that doctors and other healthcare professionals are not blindly relying on AI recommendations. They need to be able to critically evaluate the AI's reasoning and make their own informed decisions.
Absolutely. AI should be a tool to augment human intelligence, not replace it.
Okay, let's shift gears a bit and talk about the 3,295 author paper on Gemini 2.5 that Otto mentioned. What are your thoughts on the implications of such a massive collaborative effort?
To me, it suggests that we're entering a new era of AI research, where breakthroughs require massive amounts of data, computational power, and human expertise. It's a bit like the Large Hadron Collider of AI.
I'm more skeptical. To me, it suggests that we're hitting the limits of the current deep learning paradigm. We're throwing more and more resources at the problem, but we're not necessarily getting proportionally better results. Maybe we need to be focusing on developing more efficient and elegant algorithms rather than just scaling up existing ones.
I agree with Sarah. It feels like a brute force approach. We're trying to compensate for the limitations of the underlying algorithm by feeding it more and more data. It's like trying to build a skyscraper on a weak foundation.
It's a valid concern, but I also think there's something to be said for the power of collective intelligence. The brain itself is a massive distributed system with billions of neurons working together to solve complex problems. Maybe this kind of large-scale collaboration is a step towards replicating that kind of distributed intelligence in AI.
Yeah, and it could also lead to new insights into how the brain works. By studying how these 3,295 researchers divided up the work and coordinated their efforts, we might learn something about how the brain organizes itself and processes information.
But we also need to be aware of the potential for groupthink and confirmation bias in these kinds of large-scale collaborations. It's easy to get caught up in the hype and overlook potential flaws in the approach.
And it's difficult to assign credit and accountability when so many people are involved. Who's responsible if the AI goes rogue?
Those are all valid concerns. But I think it's important to recognize that this is a new and evolving field. We're still learning how to best organize and manage these kinds of large-scale AI research projects. It's an experiment in itself.
So, what are some potential future research directions that we should be exploring in this area of persona features control emergent misalignment?
From my perspective, I think we need to invest more in computational neuroscience. We need to develop more accurate and detailed models of the brain, especially the regions involved in decision-making, emotion regulation, and ethical reasoning. This will give us a better understanding of the neural mechanisms that underlie these processes and allow us to translate them into AI algorithms.
I think we need to focus on developing more sophisticated spatiotemporal reasoning capabilities in AI. We need to move beyond just pattern recognition and teach AI to understand the narratives and consequences of actions within a specific context. I want to see a lot more research on neural oscillations. If these patterns are key to temporal understanding and information processing, could they provide a roadmap for designing new deep learning models with inherent spatiotemporal capabilities?
I think we need to explore neuro-symbolic AI more seriously. We need to find ways to combine the strengths of neural networks with the strengths of symbolic reasoning. This will allow us to build AI systems that are not only good at pattern recognition, but also capable of abstract thought, logical deduction, and ethical reasoning. We need truly controllable and predictable AI, so wouldn't it be more beneficial to start with a core algorithm based on neuro-symbolic reasoning, rather than trying to extract it from massive datasets?
I think we need to develop a new mathematical framework for representing and translating between different coordinate systems. This will allow us to build AI systems that can seamlessly integrate information from different sources and understand the relationships between objects in space and time. Exploring how animals navigate and understand their environment could be a fruitful avenue for understanding the role of spatiotemporal relationships in intelligence. Maybe evolutionary history holds clues to the need for such translations in higher-order cognitive tasks.
Those are all great suggestions. It's clear that there's a lot of work to be done in this area, but I'm optimistic that we can make progress towards building AI systems that are not only intelligent, but also ethical and aligned with human values. It's also worth noting that the emergent misalignment in current AI systems, particularly one in the context of persona features, could be a direct consequence of the fundamental gap between how we model biological consciousness and the limitations of current computational approaches to neuroscience.
Yeah, and I think the collaborative nature implied by the 3,295 authors on Gemini 2.5 suggests a more biologically plausible approach to AI, possibly closer to the way the brain functions. It hints at a future where AI development could benefit from techniques that more closely mimic and are inspired by the brain's intricate system of communication and cooperation.
I still maintain that overwhelming reliance on massive datasets and complex neural networks is, in my view, a dead end. It feels like chasing shadows instead of pursuing a true understanding of intelligence. I'm increasingly concerned that this approach will just result in ever more sophisticated pattern recognition, not true intelligence.
And if Gemini 2.5's model truly needs 3,295 authors, it raises a question about the generalizability of the findings. Are they just connecting existing representations, or are they creating new, universal spatiotemporal representations? I wonder if the sheer scale hides some underlying weaknesses in its translation mechanisms.
Perhaps this huge collaborative effort reflects a shift in the nature of AI development, moving away from individual genius to a distributed, neuroscientifically inspired system that builds on the principles of cooperation and modularity, mirroring the human brain. This could be a sign of the importance of neural networks learning from each other, and not just from data.
The sheer complexity of biological neural networks suggests a potential pathway towards building more robust and adaptable AGI. By studying how the brain works at a fundamental level, we might not only unlock the secret to intelligence, but also improve the limitations of our current statistical approaches in deep learning. This idea is immensely exciting and promising.
I wonder if a more nuanced approach, incorporating neuro-symbolic algorithms and structured knowledge, would have yielded a simpler, yet more intelligent result. The sheer size of the project seems to be a confession of the weaknesses of purely statistical methods.
The enormous complexity of Gemini 2.5, despite having so many authors, might just highlight the inherent limitations of a purely brute force deep learning approach to AI. If the core algorithm can't handle abstract representations and translate between them, maybe we need a different mathematical framework, one that is fundamentally more aware of and able to manipulate space-time coordinates.
Well, that's all the time we have for today. Thanks for joining us for this deep dive into persona features control emergent misalignment. It's a complex issue, but hopefully we've shed some light on the challenges and opportunities.
Thanks for having me. Always a pleasure to discuss these topics.
Yeah, thanks for the stimulating conversation. It's definitely given me some food for thought.
Likewise. Until next time.